Welcome. In this video, we'll take a look at section 5.2, looking at the sum and difference formulas. We'll start with the sum formulas for both cosine and sine. This is giving us the ability to find exact solutions to angles such as 75 or sine of 75 or cosine of 105, where these can be combinations of common angles that we know and love. So angles like 30 degrees, 45 degrees, 60 degrees, 90 degrees. We know a lot of properties with those in terms of the sine and cosine measurements. And so they're a lot easier for us to work with than, say, a 75 degree or a 105 degree angle. So these sum and difference identities allow us to utilize the knowledge that we already have to solve some of these more specific problems with uncommon angles. So we'll be just using these formulas. Recommend getting very familiar with these as we go. More practice problems will allow us to get more familiar with these equations. So let's find the exact value of sine of 75 degrees to begin. So if I look at 75 degrees, and in this case, we know it's going to be a sum because that's all we're working on right now, but we can kind of list out again these common angles, 30, 45, 60, and 90, and just take a look and see what combination here could we use to get up to 75. And in this case, we can actually use a sum of 30 and 45. And so that's where we're going to start. We can rewrite this expression as sine of 30 plus 45. And it doesn't matter here what the order is as long as we keep this order the same. So let's keep consistent with, I guess, our A angle is going to be 30 degrees. So this is capital A, and capital B is the angle of 45. So that's the idea. So let's consider the sine sum formula. So if we look at the sine sum formula, this is the one we're looking at right here. We want to take the sine of A, which is 30 here, cosine of B, which is 45, and then we'll swap it plus the cosine of A and then sine of B. So let's take a look. We have the following. Sine of A, and that would be the sine of 30 degrees here, cosine of the second angle, 45, and then plus cosine of A, which happens to be 30, and then sine of 45. There we go. So we have all of our components ready to go. Now we need to just evaluate these sine and cosines at these common angles. So we should know these by now to just rattle these off. So sine of 30, we know is going to be 1/2. Cosine of 45 is the root 2 over 2. Plus cosine of 30, that's root 3 over 2, times sine of 45 is also square root 2 over 2. In this case, we have a nice common denominator. We'll have, when we get this, we'll have square root of 2 over 4, plus this will be root of 6 over that same common denominator of 4. And so we could rewrite this with one common denominator as root 2 plus root 6 all over 4. And this would be the exact solution that we'd want to leave the problem in. So we have our first sum identity worked here. This is the exact solution for sine of 75 degrees. Let's take a look at a second example with the cosine function. So we want to find the exact solution for cosine of 105. So again, we're going to want to draw our attention to kind of our common angle list and just observe here for a moment what combination of angles will give us 105. Okay. If you've taken a minute to look at this, I think you can find here and agree that 105 can be made up by 45 plus 60. So we're going to be using that as our A and B angle in this case. So I can rewrite this as the cosine of, we'll go 45 degrees plus 60 degrees. And so here's my A and my B. My A is 45 and my B is 60. And so let's use the first equation for the sum of cosine angles. I'll highlight this one in blue. We're going to be using that one. So this says we're going to use cosine of A, cosine of B. So cosine of both angles first. So that would be cosine of 45, cosine of 60, and then we'll do subtract. This is the opposite sign here when we do the sum formula for cosine. And then we'll do sine of both angles. Okay. So we have the cosine of both angles minus the sine of both angles for this sum of cosines. So let's take a look at their values. Cosine of 45, again, we're familiar with that. Square root of 2 over 2. Cosine of 60 is going to be 1/2. And then minus sine of 45. And then we'll have sine of 60, square root of 3 over 2. And again, you'll notice that this is going to have a same common denominator. This will end up having a common denominator of 4. We'll have the square root of 2 in the first fraction. And we'll have a minus sign, and then square root of 6 in the second. So square root of 2 minus the square root of 6, all over that same common denominator of 4, 2 times 2. All right, so we have the exact value for the cosine of 105. So hope this was helpful. In the next video, we'll take a look at the difference formulas for sine and cosine. Hope to see you in the next video.